Good morning, students. I am Raghavendra of Learn with SR channel, and I have started teaching students about GATE. I am going to solve GATE papers for students. So, students who are in electrical and electronics, electronics and communication, and instrumentation technology, they can be benefited from my lecture. And I am planning in my mind to solve problems, gate problems. So to start with 2022, from 2022 I am going steps backwards, retracing the steps back. 1991, I have a wide spectrum of problems, and I am going to solve them one by one in my upcoming classes. And to start with, I will begin with network analysis. As we all know that students study network analysis in second year. Second year, network analysis is a very important core subject, and I am going to solve problems on network analysis from these question papers. Now, I will now to start with. This is a 2022 EC stream paper. EC stream paper from and problem on network analysis. The current I in the circuit is dash. So this is a 2-mark question. As soon as you look into this network, so here this is 5 volts, 5 volts, 5 volts, 2 kilo ohms, 2 kilo ohms, 2 kilo ohms, 10 to the power of minus 3 amperes or 1 milliamperes. So this is the network. As soon as you look into this network, you have to find this I. So readily it should come to your mind. You have to use KCL and KVL. To solve this problem, you require KCL, KVL. Basics are very important for students. Now what I will do is, making use of KCL, I will mark currents in all the branches. So this is I, and this is 1 milliamperes. So whatever current that flows here will also flow here same current, because this is a current source. A current source maintains this current in this branch. So this is 1 milliamperes. This is I. Therefore, what is, if you apply KCL here, the current here is I plus 1 milliamps. I plus 1 milliamps. So I 1 milliamps and I plus 1 milliamps. Now, having written current in all the branches, you apply KVL to any closed path. Now I will apply KCL to this closed path. You can also apply KCL to this also, or you can apply KCL. But if you choose this closed path, there is no current source. So that is why I am taking this closed path. Apply KCL of KVL. So 2000 into I. 2000 into I. Voltage drop. Next, here drop here is 2000 into I plus 10 to the power of minus 3. I plus 10 to the power of minus 3. I plus 1 milliamperes. Next, a rise in potential of 5 volts. So that is minus 5. Minus 5 equal to 0. So this is the equation resulted due to KVL. If you solve this equation, I comes out to be 0.75 into 10 to the power of minus 3 amperes. That is 0.75 milliamperes. So this is how you have to solve problem. So this is a problem based on KCL, KVL knowledge of network analysis. Now coming to second problem in this class, again from EC stream. This is the problem. 3 volt source, 1 ohm, 2 ohm, 10 ohms, 1 ohm, 3 volts, 2 ohms. What is current through 10 ohms? So this is the 2-mark question. What is current through 10 ohms? So as soon as you look into this, you must know one basic, one very important basic. That basic I will explain. I will consider a 2 volt source, a resistance of 1 ohm. What is current through 1 ohm? 2 divided by 1, that is 2 amperes. 2 amperes. So 2 amperes comes out from positive terminal of the battery and 2 amps enters the negative terminal of the battery. So as long as this battery is supplying current, 2 amps comes out from positive terminal and 2 amps enters the negative terminal. This is a very important point to be keep it in mind. Now, keeping this point in mind, now let us go back to the circuit. Now in this circuit, for example, if you choose this current as X and if you choose this current as Y, so the same X must enter the negative terminal here, and here also the same current Y must enter the negative terminal of the 3 volt battery. Now if you assume that some current is flowing through 10 ohms, then what happens here? What happens to this current? The current through this becomes X minus I. So X minus I is different from X. Whereas here current Y, a current I, and the current here is, on applying KCL here, Y plus I. So Y plus I is different from Y. So this condition cannot be satisfied. Therefore, we have to come to a conclusion that no current flows through 10 ohms. In this situation, no current will flow through 10 ohms. Then only, if I is 0 here, then only current X flows here, a current Y flows here, and a current of Y enters negative terminal. So condition is satisfied. Therefore, the answer is the current I through 10 ohms is 0. So this is how you have to attempt problems on network analysis. Thank you. In the next class, I will continue with some more problems.